Today we are going to study about conservative forces. So a force is a conservative force if the work done by that force, if the work done by a conservative force depends only on initial and the final configuration. Now we have known two forces up to now, two internal forces, the spring force and the gravitational force. And the work done by the spring force is given by half kxi square minus half kxf square. So in order to calculate work done by a spring force, we just need to know what is the initial x value and what is the final x value. So it doesn't matter what happens in the path. So it means that this work done, it depends only on initial values. Similarly, the work done by the gravitational force is given by mgyi minus mgyf. So the work done by this force also depends upon only on the initial and the final point. It doesn't depend on the path by which you reach from initial to the final point. So it means that these forces, spring force and the gravitational force, they are conservative. While this is the first condition which should be satisfied, but the second condition is that the work done by a conservative force through a closed path is zero. Now what is the meaning of closed path? Closed path means you start from one point, go around, and then come back to the same initial point. So this means that xi will be equal to xf, or the initial coordinate will be equal to the final one. Initial condition will be equal to the final one. So if this is the situation, ws will be 0. Also, if in the gravitational force, if yi is equal to yf, then the work done by the gravitational force will also be 0. So it means that these forces, spring force, because this force has a work which depends only on the initial and the final points, and it turns out to be 0 when xi is equal to xf. So spring force is a conservative force. Similarly, in the gravitational force, it also depends only on the initial and the final point, the work done by this force, and in a closed loop the work done is equal to 0. So we can say that the spring force and the gravitational force, these two forces, they are conservative forces. Now let's take an example for non-conservative force also. So it means that for a non-conservative force, the first and second points, they should not be satisfied. So an example of conservative force is frictional force. Now the frictional force, if we have to find out the work done by frictional force, will it depend upon the path or will it only depend on initial and the final points? Now work done also means energy. So energy lost when an object is moving. Let us say that an object moves from A to B. And when an object moves from A to B, there will be a loss of energy. And that loss of energy will be, which will give you the work done by the frictional force. But if, on the other hand, this object, instead of traveling in a straight line, let's say it travels like this, then, so if the loss of energy is E here and the loss of energy, let's say it's E1 here and it is E2, then the loss will be more when you move a larger distance. So it means that E2 will be greater than E1. So it means that this energy, it depends on the path. It doesn't depend only on the initial and the final points. So it matters from where you are moving. The path matters for the frictional force. So maybe if you move from another path and you travel a larger distance, more heat will be generated and there will be more loss of energy. So it means that the frictional force is a non-conservative force.